First, it's a pleasure to be back here in Korea, and if I must apologize, I did get off a plane this morning, so I may not be the most energetic today. But I want to turn back before we get going and think about our industry for a minute, and I'm going to close with that a little bit. About 35 years ago, there was an infamous, or famous depending on your perspective, report came out from McKinsey & Company saying, gee, the market for cellular in the United States is about 1 million customers. Yes, very true. We are one of the most successful industries on the planet, and we have been on that. And I think our challenge for all of us, as we think about our movement through the Gs, is how do we keep that success going? And 6G, as well as 5G, is one of the opportunities for doing that. But I challenge us all to really work to make this move forward, all of us who are in the community. So I'm going to talk a little bit about the vision and technology, and I'm going to start off just saying, hey, where we are on 5G. Now, the first launch of 5G was really in the end of 2018, though in reality it was the middle of about 2019 before we really started to get things going right with devices and things like that. But we started off with a good foundation. And one of the differences between this G and many of our previous Gs, as we really looked at expanding its usage beyond just the traditional enhanced mobile broadband or communications to the cell phone with a little bit of IoT and other stuff that has existed. We're still challenged now, in many cases, with really making that part of it really happen. So if I go back to release 15, that was our very fundamental basis. We really did a few important things. We started with a new platform, and one of the nice things about our new platform is we made it a bit more flexible. So as we move forward, we can have that flexibility. We made it so that we can actually, to some extent, albeit with some constraints, which are not always the best, to be able to overlay it in some sense in the same spectrum 4G. We added the biggest, to me, one biggest performance enhancement for 5G was the ability to go up to what we call massive MIMO, i.e. many antenna elements here, and to use these in an effective way. We'll be continuing to enhance upon that. But then with release 16, we ended up adding a few more things. We added the ability to operate with the same basic technology in unlicensed spectrum. It would be nice to actually see that actually coming to true fruition in usage there. And there's reasons for that because of the availability of licensed spectrum, particularly for certain types of applications. We started to introduce additional enhanced positioning things. We introduced a side link capability, i.e. device-to-device communications, and I think there's tremendous opportunities in some of those particular areas. And then really focused on really expanding what we called at the time ultra-reliable, low-latency communications, or the ability to really meet certain grade of services. Now that's all sort of enhanced itself with the inclusion of time-sensitive networking constructs and all of that are coming out of the IEEE activities in 802 there. And then we continue to move forward. One of the most interesting things, which I'll talk a little bit about later, is now this beginning of what I will call the merging of non-terrestrial networks, i.e. satellite systems, okay, with terrestrial systems. And how are these going to be used effectively? And how does the business really come about and happen in that way? And now, as we move forward into what we call 5G advanced, i.e. release 18 and beyond, what other capabilities are we going to have? So we're going to continue to have a 5G path moving forward, as well as we're going to start working at some point, and I'll get to that a little bit later, on the 6G path. But I should note that this, what 3GPP calls 5G advanced, may be slightly different from the commercial world on what people call 5G advanced. I'm hearing people call sort of almost anything past release 15, where all these new capabilities is becoming 5G advanced. So, Now, let me just turn to a few applications, and let me just chat about a couple before I get into a couple of the important ones at least people have been focusing on. One of our challenges with this flexible platform is to expand us into new opportunities and new areas. And not only are we bringing in the toolbox, okay, of communications capabilities, but there are many new things, such as Wentong talking about AI, and I'll address that a little bit later, that are coming into these things. One of the most impressive things that I have seen recently is coming from John Deere, one of the big agricultural machine companies in the United States, and actually worldwide. You find that they're using a combination of communications and AI to do much more effective crop management and control. They now have sensors on these tractors, which then, through the use of AI, can identify what's a weed and what's a good plant. And then with the weed, they basically do a little spot treatment with the herbicide of that particular weed, much reducing the needs for genetically modified plants and the amount of herbicides and pesticides that are actually used. Communications, locations, information sensing through GPS and other means are used to keep very accurate track of where that farm equipment is in the field. A lot of this all being made by the technology that have been developed by many of us here. Now I'm going to turn to what has been one of the hot things here, XR, or the metaverse. It's been one of our, I'll call it, poster childs, at least by many people, for what we hope to get from 5G. And we've been certainly working on trying to make that happen. But there are a lot of challenges. We have certainly seen very different directions. We saw Apple come out relatively recently with their glasses and goggles, a different model than many of us have been looking for. We don't yet know which way is going to really end up, but theirs basically has another device that's sort of connected to you physically, i.e. on your belt or some other where, with a cable essentially going to the glasses. And they're moving all the processing off to that. Our nirvana, where we'd really like to get to, is just as we're able to with a smartwatch. That is to be able to have communications going directly to the glasses. There are a lot of challenges in doing this, okay? And we'll see other mechanisms before that. We'll see, for example, Wi-Fi type communications going from the glasses to phone and then off into the server or an edge server. And why do we have to deal with some of these things? One of them is, hey, you can't have a lot of heat up here. Your head doesn't like it. We have to deal with things such as human factors issues or SAR type of issues. We have to deal with the limited size and battery. We're continually working on getting the technology to this nirvana and this niche. In addition, we're moving off to the steps which are being done by many companies of how do we build much better looking glasses and goggles. We've actually made big steps forward over the past few years. We're starting to get glasses and goggles which are starting to be real and realistic. But we still have a long way to go in this particular area. If we can get here, this will drive a lot of our data rates and our communications. Because doing all the processing in the device, i.e. the glasses, or even in your cell phone, is probably not possible for very high-end applications. We'll be needing to do these in the edge, and 3GPP has been clearly looking at a lot of some of these issues, and particularly what we will call split XR. It also is a potential driver if we can get this system deployed and used considerably as a driver for 6G, and a reason for us to go out and build and develop 6G networks and to be able to drive to enhance capacity and quality of those networks. By the way, one of the big things when I talk about quality is really important, This is an application that drives us to real quality in our networks. If we're going to be doing processing in the cloud, or the edge cloud as we call it, near the thing, so we have to lay down, we still have limitations on the transit time from the time we move our head to the time that things need to show up in the glasses. Somewhere around 20 milliseconds round trip. If not, people get tired, get drunk, and have all sorts of things. But what's important in this is we can't have, that does not allow us time for much in terms of retransmissions or anything like this. So we have to design our networks for real, ultra-reliable, low-latency communications capabilities. And to be able to get to this universality, that people can walk around the streets and all that, we need to have tremendous coverage. Okay, it's just not coverage in one or two spots. It's good coverage throughout. And this coverage, I think, will be a theme throughout, and I think a thing that we need to talk about and continually work to. Now, I wanted to move off to another one, area of application. And I'm using this one because Qualcomm, to some extent, has become, through some vision of a number of years ago, that the reality is a lot of the processing in the car is exactly what is in the cell phone. The head unit or the display unit, hey, has a couple displays, has a couple cameras back in those days, and we got to do some processing. Hey, that's mostly what's in the cell phone. And by the way, yes, there's a communications thing. By the way, that all started with GM OnStar 20-some years ago with the communications and all that. But it's been an interesting wave where there's a tremendous opportunity, and many companies here have sort of jumped on this to really move forward into this entire space. As this auto industry, as one of the major industries, which needs to move from what would be considered a heavily emitter of greenhouse gases to one that is significantly cleaner through electrification, and also the desire to reduce the accident rate and death rate on highways. So, huge opportunities here. And just talking about some of this, there are a number of things. Cars are coming out, pretty much now every car has cellular connectivity in it. It's going to be moving now to vehicle-to-vehicle communications connectivity, as well as many other very sophisticated processing things. And where does communications to some extent fit in? Well, we've been talking about this for a number of years. Vehicle-to-vehicle communications for avoidance of crashes. And I just want to point out, there was just a few weeks ago in the United States, a crash in the state of Louisiana, where 180 vehicles piled up because of hitting fog and the lack of the ability to signal in advance. This is a type of thing where eyes don't work, okay? Cameras don't work, okay? And these things occur every couple of years where you have a major pileup of things. Korea and other countries have probably had similar things. This is where we need to have a longer distance type communications. Why do we say we need to do vehicle to vehicle versus going through the infrastructure? The issue is ubiquity of coverage and delay, okay? But that doesn't mean that that's the only thing that we need. We need to be able to get wider area situational information, to be able to update maps, to be able to provide other things such as routing, congestion, and all that. This brings in the ability to connect to the cloud, the importance of the cloud, and the importance of both vehicle-to-vehicle communications directly, as well as vehicle-to-infrastructure and network communications. One of the things that's emerged over the past few years is the issue of vehicle-to-pedestrian, I will call it vehicle-to-bicycle, vehicle-to-scooter, or what we typically call in the United States vulnerable road users, okay, other than those in the vehicle. This is another tremendous opportunity for us. The death rate and the accident rate for these people who are much less protected because they're not in the cocoon of a car with metal around them is something that's really important to address from a societal thing. And as we encourage more and more people to use alternative transportation mechanisms than the automobile, these become important aspects that we need to address from a societal perspective, as well as from an engineering and technology perspective. And we're going to use the technology that we've developed as this community to basically help and move forward in these areas. I do want to talk about satellite systems as another opportunity for us. This is a very interesting thing. We moved off, and I'll just say it, satellite systems have become, perhaps as a result of Elon Musk and SpaceX, okay, is new launch vehicles, bringing the launch costs way down. By the way, he's not the only commercial launch operator out there. But through that, the other types of low orbit or medium orbit satellite systems, it now seems like everybody in the world wants to have their own system up there. We'll see how this all plays out from a commercial perspective over the next few years. But there's tremendous interest in how do we bring together the economies in a massive scale that we have in the cellular industry, okay, to significantly reduce the cost of the ground platforms. There's been another tremendous interest, is where we don't have coverage or it's not economical to provide that coverage with terrestrial cell sites. How do we get coverage to this cell phone? We saw the first real commercial launch of this with Apple being able to do some simple emergency services, okay? I don't know whether that's going to cut on very well. My sense is it's probably not at that level of simplicity because the community that wants that is relatively small. Okay, but there's a lot of opportunities. We have done demonstrations now using Iridium. We're working on NB-IoT type capabilities as a first next step in that. And then there will be how do we provide even greater data rates and all. But the challenge, of course, is the link budget to these satellites. And how do we get a useful service here? Now, we can only do so much in the form factor of a cell phone, okay, and the requirements of transmit power limitations that we have in a device. So it does mean a bit from the satellite community to how do we get to bigger satellites, how we design things, by the way, bigger satellites, I mean antennas which are bigger, or we have greater directivity in those antenna arrangements and things like that to cover the link budgets. My desire is we'll be able to get to good voice communications and reasonable data communications in a satellite system in a number of years. We're still in our infancy. So one of the questions is, how do we use this? The satellite community says, oh, we should open up all of our terrestrial spectrum that we use for cellular to be able to use for satellite systems. There's a real question here. Who now controls the use of that spectrum? Is it going to be the traditional cellular operator or the satellite? Is the satellite an adjunct? So there's also a business sort of yin and yang going here between these various communities. And I think it's really important for us to think through this and how do we do this properly. By the way, there's another real opportunity for our capabilities, which is to put a bigger antenna in a more fixed application, where people are talking about, hey, maybe for universality, we put an antenna in an automobile that has a little bit more gain. And so now we can have more universal coverage, particularly in rural areas where the terrestrial coverage is not as good. So, very interesting challenges. And so one of the questions here as we go forward, and by the way, I'm running slow, is how do we move forward on satellite systems and how do we use those in 6G? One of the other really important things happening right now, and I couldn't say anything without talking about AI. And I think it's really important to look at AI in its totality and how we approach it. Today, we actually have a lot of processing in our cell phone today that's AI. Qualcomm's been supplying neural processors for a while, and many of your phones actually have that. It's being used for a number of applications today in it, but these are sort of constrained. But now the bigger question is, how do we use this expanding area of AI in an appropriate way? And I'm going to talk about that, because one of the things is, people say, oh, AI is going to be done in the cloud. But there are problems with that. We have issues of power consumption, okay? We can do things a lot more efficiently in many cases on the device. And so the questions that will be emerging is, what do we do on the device? What do we do in the cloud? And how is all that going to come about? And this is going to cause a lot of how do we work with the community, such as Microsoft, Google, whatever, that is really focused on providing cloud services. And how do we work in what we do on what's on the device? Now, I wanted to turn to another aspect of AI ML, which is really what we're going to be doing maybe in the 5G, later 5G timeframe and such. Well, one of the things is that we're going to do processing, and we can use the algorithms directly self-contained in the device, the phone. Okay? So there's no interaction sort of between the network and the phone. That's an enhancement. But one of the things is, and I'm going to be brief on this so I can get to the last part of my presentation, is how do we coordinate all of this now when we want to interoperate and we want to optimize between the network and the device, or the infrastructure and the device. This, to some extent, is a little bit of a challenge on how do we do this. So that, for example, as we update our training, for example, on the device, then the network knows what we're actually doing and not doing. So there are a lot of questions here which 3GPP will be exploring. It has been exploring now, thinking through this. I didn't provide a slide, but I did want to talk about one other thing, which is the world of Open RAN. And this is an area which we've been exploring quite a lot. The community set up the O-RAN Alliance a few years ago. It's happening, and they've been coming out with specification, particularly for the open front haul. Recent updates and enhancements to that, which was really helping with sort of the massive MIMO arrangements. And from that arrangement, we'll probably be seeing a number of deployments in the 5G timeframe. Qualcomm has developed a line of chips, what we call our CSM line of chips, cell site modem, coming back from the terminology we used back in the 3GPP2 days when we actually had such chips. But the point is, this is an opportunity for us, and I think this opportunity will see itself much greater in the 6G timeframe, when companies will have the opportunity to design from the get-go to this type of open interface. Now, let me move quickly here into the 6G timeframe, as I've sort of been preventing a bit on 5G. But there's a lot of stuff going on in discussions and all that of trying to set up a plan for 6G. But I think we'll really see this outside of the ITU, starting to hit 3GPP, probably with a RAN workshop. And now I know SA1 is going to be studying things and having discussions before then. Probably about early 2025, there'll be a workshop. And I think at that point, many companies will show their hands, i.e. they're thinking in some level of detail on what we'll see in 6G. But our challenge here as we move forward is to create a platform that improves upon 5G and creates an interest so that there will be interest to deploying this 6G platform. By the way, we're seeing here in a time frame, but we're expecting probably 2028, 29, the first versions of the 3GPP specifications to emerge, and hopefully deployments will be soon thereafter. Continuing from this vision that Rentong talked a little bit about in his presentation of what we are getting now from the ITU, which has been working on this and looking at it at sort of a high-level visionary capability for the past few years, is we've added a few more dimensions to it. One of the ones is integrated sensing and communications. Rentong talked a little bit about that in his last presentation. This is the ability to designing some of our waveforms and using our capabilities in here to provide location, which we've been doing for many more years, but also more a radar-ish type of functionality in some ways. Our challenges here are not the technology and being able to do it. Our challenges here are how do we make this into a good business and a successful business for the community. We're all going to come up in 3GPP, Qualcomm, and Samsung. Well, we'll have, I should say, not forget LG. We're all going to have our proposals here, okay? And we'll come up with the outcome. But as I said, the real question is how do we use this in an effective way to provide societal benefit and for business? One of the other things that I'm really interested in here, which is a real challenge that we have in this industry, is coming from this area of sustainability. Now, everybody's talking about sustainability, but we have seen today that our communication systems, and one of the major costs for our operators, is the operational costs of electricity and power. How do we focus on that? Now, how do we focus on getting the infrastructure side, power consumption, down significantly? There's two directions I think we're going to work a lot in. The first dimension is going to be what we can do in this 3GPP standards arena. The second dimension, which is really the implementation of this, and how do we do this in a way that's... By the way, this problem is only getting worse as we start enhancing with AI, ML, and machine-level communications. Those processing takes a lot of power to do. Okay, I'm going to about out of time. Lots of technology will be coming here towards 6G. Companies are talking about many of these things. I'll talk about new spectrum bands just in a minute. People talk about terahertz. I'm not so sure on terahertz, at least for our normal communications. I think we really need to focus on the lower frequency bands. We need to think a lot in the 6G timeframe of bringing back millimeter wave to the forefront. We have a huge amount of spectrum there right now. We have challenges on propagation, okay? We have challenges on first generation, I'll call it our 5G stuff, really getting the performance out of it. A lot of issues related to implementation. I think in many cases at Qualcomm, we've done a good job at figuring all of those out and doing well. But I think it's a challenge for the entire industry to be able to use that spectrum in a much more efficient way. I want to just quickly turn to spectrum. We have WRC 23 coming up. It's a real challenge right now in setting ourselves up for spectrum for 6G. Okay? People are talking about, well, I'm going to just go quickly through that. There's a lot of spectrum, which I'll call it normal operations. It's sort of codifying to some extent what we've done and what we're using today, sort of at an international level. I'm not worried about that. But there's two bands and two spectrum areas of tremendous discussion interest right now. One of them is the upper 6 gigahertz band, i.e. that spectrum from 6425 to 7025. Okay, this is a spectrum which has been allocated for unlicensed operation in a number of countries. But people are discussing, hey, should that be IMT spectrum, i.e. spectrum for cellular? Or should it be shared in some way to be determined if sharing can work appropriately? We think you can do some sharing effectively, but the question is how well, how effective, and is it going to be economically interesting where there are spectrum options going on? That's one area. Our general view is that it varies from region to region on that particular spectrum. The one thing I do want us to focus on, just as I end here, is finally the spectrum that is basically will be dealt with in potentially Agenda Item 10. Studies for new, hoping as Qualcomm that we can get studies above this spectrum here, say the 7 to 8.5 gigahertz, or maybe slightly above in certain regions of the world where the spectrum or so. Hopefully, for challenges in sharing are difficult. is I think it's really important for us to get in spectrum. And why is that so important? Because spectrum has often been, for many governments, the driver to deploy of cellular communications. I hope all of this works so that we can really, in the studies for spectrum in this, about that afterwards. Finally, I'll comment. We're seeing the march of G's, 6G to 7G, 8G. I may not be around at that. I've been involved in sort of so far. I do want to bring in, not a betting person. Yeah. When I go to Las Vegas, I don't, but I'm wondering to lay down some bets here. Where is the first deployment of 6G going? I'm going to bet here in. They've been the first deployment in 3G of CDMA 2000, one of the 3G specs, 4G, 5G, and so on. Okay, I'm done. Thank you very much.